Looks like we're live. Hello everyone and welcome to yet another Azuzin session. Let's make a little bit of an announcement and officially start the stream as usual. So red circle live on Twitch. And what are we doing today on Twitch.television? That's a very interesting question, and today we're doing OpenGL batch renderer for text editor in C. So let's give the link to the Twitch channel where all of this shit is happening. How do I type link? twitch.tv/Toding, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has been officially started, and today we're gonna continue developing the text editor that we started to develop I think a year ago, but then I put it on pause and now I went back to it. So you can find the source code to this editor in the chat or in the description if you're watching on YouTube. Right, so let's take a look at the text editor. What do we have in here? I'm pretty sure I already fetched all these changes, but let's actually recompile just in case, just to be sure. Just to be 100% sure. Right, so if I start the text editor, so this is what it looks like. It stands for Dramatic Text Editor, that's why it's called DED. Right, when you start typing, you have some epic camera action going on. Right, so as usual, you can type some stuff in here. Right, so maybe here I'm gonna do stdlib.h, and then let's actually write some sort of a hello world. 1, 2, 3, 4. It doesn't really have outer indentation. It's a pretty basic text editor. Right, so it's meant to be just a show off, right? So nothing particularly special. So, and on the previous stream, we were simplifying the render for this text editor. So before we had rather overcomplicated renderer, like we had a separate renderer for just a cursor and separate renderer for glyphs. And I'm trying to consolidate all of that into a single renderer that looks like a SIMP, which is the graphics library that comes with Jai. Right, and Jai is a programming language that is developed by Jonathan Blow. So I'm not really sure if that's the name of the language, right? Because John himself never actually calls this language Jai. He refers to it as the language, right? So nobody really knows what's the name of the language, and Jai might be a random combination of letters to denote the language, like XKCD, right? So do you guys know that XKCD doesn't really have any meaning behind it? It's just a random combination of letters, right? So yeah, so Jai might be the same as well. Nobody knows, right? So the actual name of the language may be revealed in the future, right? So, and this language has a graphical library that comes with it, right? It's called SIMP, and it's rather cool. It has like immediate API where you have like immediate triangle, and this is probably the most interesting function in here, right? It accepts the vertices of the triangle, the corresponding colors of the triangle, and corresponding UVs of the triangle, and also a normal, probably for 3D stuff, but we are not implementing that. Right, and depending on the currently set shader, it will do different things, and there are at least two kinds of shaders. The shader for color, I think there's literally like set shader, let me actually find the function, grep set shader, there's a bunch of functions like that. So you can, yeah, set shader for images, set shader for color. There's at least two kinds of functions, two kinds of shaders. Depending on which shader you set, this function is going to behave differently. If you set the shader for color, it's going to just use the colors for the vertices, and it's going to render you the gradient. And stuff like that. If you set the shader for images, it's going to be texturing that triangle using these specific UV coordinates, right? And this is actually a very powerful API because it can be used to render pretty much anything, right? So it's going to be very useful for our text editor specifically. So let's actually run the text editor one more time. So if I go in here, so it's going to be something like this. So as you can see, we have a bunch of things in here. We have the cursor, and the cursor could be just two triangles, right, with the shader set to color, and each glyph could be a separate quad, which is also two triangles, but with the shader set to image, right? So, and image could be basically an atlas of all of the glyphs. Right, so, and we could use basically the same API for rendering the cursors and the glyphs. And on the previous stream, we literally started to do that, right? We introduced simple renderer, right? So here is the simple renderer, and in a simple renderer, as you can see, we have a simple render triangle. Off screen, I also added a simple render quad, right, simple render quad, which basically takes 4 vertices and automatically splits them into triangle for you, right? So, and also off screen, I got rid of the cursor renderer, right? So now this cursor, this specifically cursor, is already rendered with a simple renderer. Right, so in the source code, if we take a look at the source code of the main thing in here, so I think, let me take a look at the function. So this is the function where the scene is rendered, and if we go down somewhere there, here is the cursor, right? Maybe somewhere here. Yeah, here's the cursor, and we're rendering the cursor with the simple renderer, right? So we're not using the simple renderer for rendering glyphs because we don't have a support for images in simple renderer, and this is something that I want you to develop today. I want you to spend some time today. So the UV coordinates in a simple renderer do make sense. So for now, they're basically ignored. They're not used by any of the shaders. They're simply ignored. So I think we'll have to write like a different flavor of the shader, right? So right now we have some shaders in here. Some of them are going to be obsolete. So right now the simple renderer uses only these shaders, right? So we just set the vertices and also project the camera and stuff like that. And in fragment shader, we just set the color. Right, so we'll have to create another shader that accepts UV coordinates and queries the texture sampler and just, you know, sets the color of the pixel according to the UV coordinates and stuff like that. This is something that we'll have to do. And once we've done that, we can finally get rid of the glyph renderer and only use the simple renderer for literally everything. And we're going to keep using it for literally everything from now on, because once you have the triangles, you can basically render any shape. And on top of that, if you have textures, you can just texture them however you want. And with the more different kinds of shaders, we can even add interesting effects and stuff like that. So that's basically the idea. So we've got this up. By the way, Nico Red H, thank you so much for 15 months of Twitch Prime subscription. Thank you, and welcome back to our epic cooling club. I don't know what I'm doing. Anyway, so let's actually go ahead and do that. All right, so let's go ahead and do that. So I'm gonna go into the shaders. So, and I need an ability to basically switch between the shaders, right? So I want to have a function, something like simple renderer set shader, right? So similar to how we have that in Simp, right? So as far as I know, in Simp, as already demonstrated, they literally have a function set shader for color. I'm not sure if we're gonna have like this stuff exactly like this. Set shader for color. So they literally have functions called like that. And if we find the definition of this function, right? So let's actually find the definition of this function. We can't really find the definition of this function for some reason. I'm not really sure why. Probably because I'm searching in the examples. I have to search like a little bit higher in the abstraction. Right, so basically what it does, it just, yeah, it's a simple wrapper, and it sets the specific shader. Interesting enough, it also keeps track of the currently set shader, and if you're trying to set the same shader again, it doesn't really do that. And is it somehow very expensive operation to do so? I'm actually rather interesting, like why do you need to do that? Right, so why do you need to sort of like cache your decision, right? So it only makes sense if it's somehow a very expensive operation. Oh, maybe it's not really expensive, it actually invalidates the locations of the uniforms. Okay, I see that. Right. But I mean, actually getting the locations of the uniforms might be expensive operations. Who knows? Maybe this is like expensive. I'm not really familiar with OpenGL and performance applications of constantly getting the attributes locations and stuff like that. But that makes sense actually. That's pretty cool. Right, so as soon as you set like a new shader, you have to basically get the different locations for the uniforms that you're going to constantly set, and so on and so forth. So we also call to the backend. Well, what's interesting is that there is a little bit of like a separation of the backend, right? So the code kind of implies that you're going to have several backends, presumably OpenGL, DirectX, Metal, and so on and so forth. But right now there's only OpenGL, right? So which kind of looks funny, but I mean I understand where all of that is coming from. Right, so essentially in the future we're gonna have like several backends and stuff like that. Okay, anyway, so I don't know, so today's stream is about C. I don't know why I'm doing like Jai and stuff like that. So I'm getting inspired. I'm getting inspired by someone else's code, just like a neural network, you know. Neural networks are just like humans, they get inspired by some other work. It's not stealing. It's not copyright laundering. It's not copyright laundering. It's neural networks getting inspired. Oh, I'm sorry. Yes. How dare you say that neural network is stealing your work? It's just like you. It's getting inspired. Are you against the progress? You're against the progress. I can see that. Anyways, I'm sorry. Let's take a look. Simple renderer, right? So we're gonna have something like set shader, but how are we gonna be setting the shader? I was thinking about like introducing a shader as the enumeration, but I'm not sure. I feel like maybe I already have the notion of a shader somewhere here. Right, I thought maybe I introduced the type, but yeah, maybe it doesn't really matter. We can always introduce the enumeration. Right, and we're gonna say shader, and this one is gonna be shader for color, right? So we're gonna have shader for color and then shader for images, right? Something like that. Maybe just to not plagiarize too much, let's actually call it a shader for textures, right? So to specify that it's specifically related to the simple renderer, I think I'm gonna call it simple shader, right? So simple shader. Simple shader. Simple shader, and this is the shader. And we also probably need to take the simple renderer here as well, right? So this is the function that we'll need to implement. Simple renderer, and let's go ahead and just implement this entire thing. All right, so when we are initializing the simple renderer, we are compiling only one shader in here. In fact, we're accepting two paths, right? So we're accepting the path to the vertex shader and the path to the fragment shader. What's interesting is that I don't think we'll need to have a separate separate vertex shader for the images, right? So because if we take a look at the shader, so simple vertex shader, so here we just, yeah, so we're just outputting the colors, but maybe one of the things we'll have to do is also output UV coordinates, right? So out UV, and it will be up to the fragment shader whether to get this information or not to get this information, right? I wonder, like right now the fragment shader doesn't care about the UV coordinates. I wonder if this entire thing is going to compile at all. Right, so let me actually rebuild this entire thing. Ranzel117, thank you so much for tier 1 subscription. Your first subscription, by the way. Thank you, thank you, thank you, I think. And welcome to our epic simple renderer club. All right. So what do we have in here? Can I just say unused SR and unused shader, right? So there we go. So everything seems to be compiling. And what I want you to do, I want you to literally just run this entire thing and see if the shaders are compiled properly. Right, the shaders are not particularly compiled properly because I made a oopsie-doopsie and a little bit of a fucky-wucky, because UV is actually 2-dimensional vector, not 4-dimensional one, right? So, and apart from that, everything seems to be working. So even though, like, the fragment shader right now ignores the UV coordinate that we passed it, so it is totally fine. Like, I'm not really familiar with OpenGL that much, so I don't know what kind of pitfalls are awaiting me, so cheers for that. Okay, good. So I suppose we'll need to just write the fragment shader for textures specifically, right? So I think I'll need to rename this thing. So let's actually call this simple color, right? Right, so this is a simple color, and we'll need to introduce another shader. What the hell is going on? Simple texture. So it's going to be fragment shader. Let's open the color in here, and let's start sort of, you know, copy pasting, getting inspired, not copy pasting. Right, so core, and what we're going to do in here. So we're gonna ignore the color, and we're only gonna care about the UV coordinates, right? So, and UV coordinates only make sense if you have the sampler for the texture. So as far as I know, we have the sampler in the glyph renderer. So yeah, here we go. So it's called font. But I think I'm gonna call it just a texture. Texture is already freaking taken. Yeah, I'm gonna call it an image, right? So let's go back and let's actually call all this an image, right? Because it makes sense. Because the texture, the name texture is already taken. Simple renderer, textures for images, for image, a simple one. All right, so this one is going to be an image, and let's go back to the glyph, right? And can I let you know what is going on? There we go. Okay, cool. So right now, this shader is a little bit complicated because we're also doing the rainbowish thing, right? So the rainbowish thing requires a little bit of a math, as you can see. But for now, I'm going to actually ignore that, and I'm going to simply just do that, right? So we have glyph UV position, glyph UV size, which I'm not actually sure why it is like that. Yeah, I think it doesn't really matter for this specific case. Oh, this is because it's instanced, right? So we're not rendering as triangles. We're actually instancing it, and that's why it's like that. Okay, so it's old stuff. Okay, so the shader should be as simple as just this glfrag color, right? And I'm gonna make it equal to that, and there we go. So we have a shader for rendering images, as simple as that. All right, so let's go to the simple renderer. And the question is, how are we going to be accepting all of that? So I'm pretty sure I'm going to be reusing the vertex shader, right? So maybe I will need to introduce like a color frag file path and something like image frag file path, right? Something like this. Simple renderer, and this is where we initialize this entire thing, right? We're gonna go through the compilation errors a little bit later, and I'll need to also store the program somewhere. So as you can see here, I'm actually storing one program, so now I'll need to store two. In fact, in the future, I may have several programs to store. Like maybe in the future, I'm going to have more shaders than just for color and just for image, right? So, and let's actually make it controllable by the amount of elements you have in here. So let's introduce count count simple shaders, right? So count simple shaders. So since this thing initially is 0, that means this value is going to be the amount of shaders you have, so I can use that as the size of this array, right? So this becomes programs, and yeah, in the future we'll have to actually, yeah, when we set the shader, we'll have to reset the uniforms and stuff like that. Also, it would probably make sense to keep track of the current shader, right? So simple shader, current shader, like as well, right? All of that makes sense, actually. All of that makes sense. So this is a color fragment, image fragment color. Okay, so simple renderer, and what are we going to be doing in here? All right, so the way it works, we are attaching shaders as an array. That's a really weird way of doing that, but I guess that's fine. Okay, so we're gonna have a color frag file path. So I suppose we're gonna have maybe, yeah, let's actually say that we're gonna have 2 of them, right? So this is going to be that, and we are initializing the shader for color, right? So we're initializing the shader for color, and then I'm compiling the shader and I'm linking the shader for color. There we go. So I'm just linking all of that. Whether I'm going to be setting, that's a very interesting question, right? That's a very interesting question. Maybe not for now. Right, so essentially I can say that here I am setting, like initializing the shader for color, right? So let's also do something like shader for image, right? So I might as well copy paste this entire chunk of code, right? So let's just copy paste it. So this one is going to be image frag file path. This is a fragment shader. We set it for the second shader in here. Right, so this one is for image, right? So this one is for image, and we are setting everything for the image. All right. Interestingly enough, I think this specific thing has to be moved to set shader in here. Yeah, it has to be moved to the set shader, and it kind of replaces this thing, I think. Maybe. We'll see how it goes. We'll see how it goes. Alrighty. So that should be basically enough. That should be basically enough. But maybe for the sake of the backward compatibility, I'm gonna just set the current shader, right? So I'm gonna set the current shader, and the current shader is gonna be a shader for color, right? So it's a shader for color. There we go. So what I'm thinking is I'll need to do the following thing. I'm gonna say SR current shader, right? So this is the shader. Then I'm setting the, like, I'm using the current program, and then I'm recomputing the uniforms for the, it's kind of starting to actually remind the JAI code, right? So I mean, it's basically the same idea, so that's why it kind of reminded. So nothing particularly special, I think. Though maybe I'm gonna do a similar thing, right? Where I would check that SR current shader is not equal to the shader, right? And only then set all of that, but I'm not really sure. Maybe I'm gonna do that later. So I'm gonna put it to do. Because initially the current shader is already 0, right? So, and I need to force it to be something else, so the cache doesn't, like, cache gets invalidated, like, I mean, cache, it's not really cache, but you know what I mean, right? So I don't really want to deal with that right now, so I'm gonna just leave it as it is. Okay, so we also have use for this function, and the point of this thing is to bind the current VIO and a current VBO. But it also sort of like sets the current program, and it made sense when we only had one program. So now we have several programs. I'm not sure if it makes that much sense, right? So I'm gonna just separate these things. So use just sets the buffers and stuff like that, and then shader sets everything else. And because of that, maybe yeah, maybe let's just not do that. Okay. Cool. All right, so let's actually try to compile this entire thing and see if it's going to compile. All right, so yeah, we don't have this thing anymore. I mean, I didn't even try to recompile, but it already doesn't work. Right? So simple caller, right? Was it called caller? I think it was called caller. Yeah, it is caller. And yeah, well, I mean, we'll have to still recompile that anyway. Right, let's go ahead and recompile. Let's go ahead and recompile. So now we have to supply several shaders in here, right? So let's supply also image, right? And there you go. Is it gonna compile? Is it gonna compile? It seems to be, no, it's not gonna compile. Okay, sure. So has no member program. Is that because I actually renamed this thing to programs? Like several of them? Apparently I did. Okay, sure. That's actually pretty good, because it kind of forces me to go through this entire thing and confirm, yeah, and confirm that I know what I'm doing. Yeah. All right, so this is that. So let's try to recompile that one more time. And this is the programs. What else do we have? This is programs, and this is programs, but this is for image. What else do we have? And also programs. Do we have anything else? Programs for the current shader and other programs. I think that's it. Okay, at least the compiler says that that is basically it. And we are working. Okay, so we have some bullshit. No matching function to call error. Okay, so the uniform was never set. Right, the uniform was never set because we don't have the location for that uniform. Yeah, we don't have the location for that uniform. We never set that texture to anything. So that's rather interesting. So let me take a look at the image. So it's that. Oh, because I'm an idiot. Okay, sure. Yeah, of course. And it doesn't really print anything, but it doesn't print the cursor. The reason why it doesn't print the cursor is because I think we never actually set the current shader, right? We actually never set the current shader. So if we do simple renderer use, right? So I think another thing we have to do in here is to set shader, and we can do shader for color, right? So we set in shader for color, and nothing here works anyway. Okay, camera scale has one component, not two. That is really weird. I suppose there's something wrong with the vertex. Let's take a look at the simple vertex. Camera scale. So it's a single float, but something, but we're passing two components in there, which is really weird. Why would we do that? Okay. So this is the uniforms scale, camera scale, and stuff like that. Okay, so that kind of makes sense, right? And if we take a look at the implementation of that specific function, I swear to God, if it's one of those situations when the thing got illuminated because it was not used or something like that, it could be one of those things, right? So I suppose something got wrong with the uniforms, right, after we got the uniforms. So we set the shader, we set the program, and then we are getting the location, the uniform location for that specific shader. So something is definitely wrong in here. I would like to see the uniform location after we set them. So let me quickly do the following thing. We got the location, right, and if I take a look at the uniforms, so what kind of uniforms do we have in here? Yeah, so this is account uniforms. uniform slot, US, okay, cool, and we're gonna do US. Okay, do we have the names for them anywhere? So I can, so there's a uniform, oh yeah, there is a uniform definition. Yeah, that's cool. So that means I can always get the name. So I can do shit like name and just its value in here. Right, so let me see. Get uniform definition for US, and this is then the name. And then I suppose I can always do SR uniform, uniforms US. I think that should work, and after that I'm gonna exit with 1. So it basically will print all of the uniforms it got in here and just like exit instantly. And something went wrong. I didn't recompile this entire thing. Right, I didn't recompile this entire thing. So now it should basically drop, but it has to be an arrow. Sure. Show me the uniforms that you've got. So scale is 1 for some reason, right? Scale turned out to be 1, and I'm not really sure what exactly is going on. So let me see. Okay, so here I'm compiling the vertex shader for the shader 0, but then I'm compiling the color fragment in here. Right, so everything seems to be fine. And then I'm setting the program for the color, attaching, and then linking everything in here. So, and effectively, I'm basically reusing the vertex shader. So here I'm setting the image, then programs for the image, programs for the image. So here is the for the color, right? So this is the for the color, and then this one is for the image. So I didn't see any problems in here, to be fair. I didn't see any problems, but it still doesn't really work. But it still doesn't really work. Okay, go. And all of the programs actually compiled. In fact, this looks all right. Right, so because we're not accepting the time, cursor position, cursor height, and last stroke into the shaders anymore. Right, it just looks a little bit out of order, if you know what I mean. Right, so if I take a look in here, right, if I take a look in here, though we do have time, don't we? We actually do have time. So we actually do have time. I'm not really sure what the hell is going on and why. Maybe I just can't reuse the same shaders when I'm linking things. Is that a thing? Is that actually a thing? I'm rather surprised. Like, I never thought about it. Maybe I just can't reuse and it just like gets messed up or something like that. Maybe that's what's going on. So what if I literally just not separate this thing and always try to compile the vertex shader for both of them? Right, so what if I just try to do it like that every time? Is it going to fix the problem? I wonder. Okay, so I mean, it didn't really change anything, but this is because, yeah. So let's actually do it like that. Really? Okay. Like, I'm not even sure if that's a good thing or not. Right. I'm really not sure if that's a good thing or not. I'm gonna explain you what I tried to do and why it... Wait, but now it works. Are you freaking serious? Did I forget to just recompile something, or... Now it works. Now this mother flipper works perfectly. It's just like, God damn it. I suppose I just forgot to recompile. And that's why you have to program in interpreted languages like Python. With the Python, you will never forget to recompile. in Python, you never forget to recompile. And with things like NumPy, you're going to be as fast as C. Right. Cheers for that. Okay. Nothing against Python, by the way. Okay, so, and the thing I was trying to do, by the way, right? So the way you compile and link shaders is actually kind of similar to the way you compile and link C code, right? Believe it or not, it's kind of similar, right? So essentially, I have a single vertex shader, right? So let's actually say it's V. So a single vertex shader, and I have two fragment shaders, so like fragment for the color, FC, right? And a fragment for the image, FI, right? So, and essentially I was trying to make two programs out of them, right? The program for the color and the program for the image, right? And essentially I was trying to link the same vertex shader, but two different fragment shaders, and for some reason it didn't work, and I couldn't understand why. I thought maybe I have to duplicate the vertex shader for all of these programs. Apparently I can do that. I think I just forgot to recompile. So maybe people who are watching that in the recording can tell me that I did a fucky-wacky and potentially an oopsie-doopsie, right? So that's what I was trying to do, and I thought it's impossible. Apparently it is possible. Okay, sure. Cool. But now we have two separate shaders, right? We use two separate shaders, and I should be able to do shit like, okay, I don't want to use the color shader. I want to use the shader for images, and now it should not work anymore. Right? It should not work anymore. In fact, we can't see anything, right? We can't see anything, and that is totally fine. So to see something, we'll have to set the UV coordinates. To render the cursor, we use SolidRect. Right, so let me actually find this thing. SolidRect is actually pretty straightforward. All right, so what it does, it just accepts the left bottom position of the rectangle and the size of the rectangle and its color, and just renders the solid color. Right. So what I want to do, I want to like create an experimental function, simple render texture, let's put it this way, image rectangle, right? So we're gonna accept the renderer, and we're gonna basically accept the same things in here, except the color, right? Except the color. So, and we're gonna be using the UV coordinates, basically the UV coordinates from 0, 0 to 1, so we're going to use the entire texture. Right, so we're going to use the entire texture. So let's see how we can do that. We're going to use a simple renderer quad, right? Simple renderer quad. We're going to start, okay, so I can actually try to copy paste the code from here. So in terms of the color, since it's a textured, I don't think the color matters that much, right? So, and like I'm providing color 4 times because it's for each an individual vertex of the quad. So the color in here, let's say it is going to be all zeros, right? So these are all zeros, but with UV coordinates, it's going to be rather interesting. So we have P0, P1, and I don't remember. Oh, here they are, right? So when we're working with the quad, these are the vertices, right? These are the vertices. So that means this one has to be 0, 0, right? So this one is 0, 0. The second one has to be 1, 0, vec2f 1, 0. The next one has to be 0, 1, and the last one has to be 1, 1. So I'm using the entire texture. By using this function, I'm basically drawing the rectangle that uses the entire texture, and the entire texture right now is the atlas that has all of the glyphs in it, right? So that's the current texture. Right, so that's the current texture, right? So what we're gonna have in here, so the simple renderer, it's actually renderer, right? So simple renderer, There we go. So we can't see shit, which is rather interesting, and I wonder why. Right, I expect to see at least something. So let me make sure that I already recompiled everything. So this is going to be the image, right? So this is the image, and I just said this entire thing. So one of the things I can try to do, I can try to make sure that we have at least something. So can I do add vector 1, right? So we're going to add like a white color to this entire thing. And if that works, that means shader at least works. Okay, so shader at least works, right? Shader at least works. It just doesn't query the texture at all. As far as I know, by default, the sampler is set to 0, and we set the I don't even know. Like, do we have to create a separate texture for each individual program or something like that? Because I don't really remember how it is working. So that's rather interesting. That is rather interesting. So let me see. It's located somewhere in a free glyph or something like that, right? So this is where we do glyph texture atlas, right? There we go. So we use active texture, and then we generate texture, bind the textures, and so on and so forth, and stuff like that. So we don't really know why it doesn't really work, right? So why it doesn't really work? That's really strange. Because I would expect it would just take that specific texture. It will just take this exact specific texture and just render it there, but it doesn't really want to do that. Maybe it's so small, maybe it gets so compressed that we can't really see it, if you know what I mean. So yeah, but we should have seen at least something, right? We should have seen at least something. So yeah. You know what? I think I want to make a small break, and I want to make a cup of tea. Right, and after I make a cup of tea, we're gonna try to understand why we can't have an access to that specific texture. So, all right. So one of the things I want you to check is, are we passing UV coordinates like correctly at all? Right. So let me see. One of the way people usually check whether the UV coordinates are passed correctly is by basically making a, how is that? I think Freya recently called it on Twitter like a square mango or something. It's when you're using UV coordinates to construct a color, and it creates like a gradient that looks like a mango. Right? I never actually see it this way, but it actually makes sense, I think. So essentially, I just like use UV coordinates 0 and 1, and that basically should construct the mango, right? Because it's going to be red, green, and it will go into yellow, right? So let's actually try to recompile this entire thing and see if it does something. And it doesn't do anything. It doesn't pass the UV coordinates correctly. God damn, that's very interesting. Okay. But I recompiled this entire thing, right? And in terms of the image here, right? So what's funny is that if I set like maybe a red color, right? If I set this entire thing as a red color, it is going to be the red color, right? So I just like hard-coded it to be red, right? So that's fine. But if I'm using the UV coordinates to construct the mango, it doesn't work, meaning that the problem is with passing UV coordinates. That is very freaking important. So, okay, so image rect, right? So I'm doing image rect, and this is the UV coordinates that I'm passing in there, right? 0, 1, 0, and seems to be fine. But also, interestingly enough, well, I mean, of course, freaking of course, I'm using solid rect. but then I'm using an image. But if I'm using the solid rect, how on earth does it, did it even affect anything there? Okay, so I feel like I have to, yeah, I have to do this thing. All right, so render image rect, implicit declaration. Okay, so basically I implemented a function and I never used it, so that's why it never worked. Okay, that actually explains it. Okay, so we have a solid rectangle, so let's actually do image rectangle. So maybe it has to be called the renderer. I think it makes a little bit more sense. All right, so this is the renderer, and we set the shader for image, and there we go. So too many arguments, and this is because we should not provide this thing in here. Are we gonna see the mango? Are we gonna see the mango? I want to see the, yeah, there you go. That's a freaking mango. My mango. Does it look like a mango, chat? Does it? Does it? Does it? I think it looks like a mango, right? So it's a UV man. Is that a thing? I'm really curious. UV mango. Is that how people call it? No, this is not how they call it. But this makes so much sense. This makes so much sense because it's a classical gradient for basically debugging UV coordinates. And I never seen anybody calling it mango, but it is mango. It's a UV mango. Right. It's actually kind of cool. I really like that. I see everyone calling it mango. Okay. What fruit is a normal map? I don't know. Let's take a look. Normal map. I just want to take a look at the reference of the normal map. Because normal map is usually very rainbowish. It's also very purplish. Right. Yeah, so this is a normal map. I don't know what it looks like. It looks like an ice cream, I would say. Yeah, kind of like an ice cream or something. Okay, so since we know that we're passing the UV coordinates correctly, we should be able to switch to the texture, and now the cursor must be the entire glyph atlas squashed into a single small narrow rectangle. So that's what we should witness. It's gonna be a mess. It must be a mess. Yeah, there we go. So here it is. It's funny that we're using like a red color in here. It's really interesting. But yeah, so these are basically all of the glyphs in here that are smashed into a single like sort of place. So that means our thing is capable of working with images, right? So it is capable of working with images, which is kind of cool, right? So that means we can use this entire stuff to render, for instance, glyphs and stuff like that. All right, so that's pretty cool. But the question is, how are we going to be actually doing all of this? How are we going to be doing all of this? So this is a dead code, we don't need that. And why, when we basically squashed everything into a single thing, why was it red? I don't really remember this being red. It probably has something to do with the fact that we're building the atlas from the grayscale images, because we get those images from FreeType library. So the way we build the atlas, if we take a look at the atlas, so where do we build it? It's a free glyph.c. Free glyph.c. Yeah, there we go. So I'm basically iterating through the displayable ASCII for now, right? So supporting Unicode is actually out of the scope right now, so it's going to be in the future, doesn't matter. Right. So, and what I'm passing in there, oh, I think I'm just literally, yeah, it's kind of funny. Yeah, I'm just taking the grayscale bitmap and I just only use the red component. Yeah, I only use the red component. And in the fragment shader, right, in the fragment shader, if we take a look at it, so free glyph fragment, how do I do that? So this is the texture color, and I use only X, which is essentially the red component of this thing. I mean, I could have, maybe not, I don't know. I wonder if there is a way to actually, yeah, the reason is because each pixel is represented by a single byte when we get it out of the free type thingy. Right, so that's basically why. But I wonder if there is a way to say, okay, even though the pixel is 1 byte, right, even though the pixel is 1 byte, could you just like set that value to all of the component, maybe except alpha? Oh, it's might not work like that, right? So it's easier to actually, you know, make it as red, right? Make it as red. And also, if I just start using this to render the glyphs, we may lose the cool rainbowish animation that everyone is so impressed with, right? So this cool rainbowish animation is going to be lost if I'm going to start using the new renderer, right? Because currently the new shader doesn't really support that, which probably means that we need to introduce another kind of shader, right? So another kind of shader. So let me see if we can do that. So, and the shader is going to be basically expecting the texture to be reddish, to have like only a red component, and also it will apply the rainbowish animation, right? So yeah, I think I've come to the conclusion that this is precisely what I want to do. Right, so we're gonna introduce another one. So for the image shader, for, I don't know, for epicness, right? And this is gonna be the shader essentially for the rainbowish thingy and stuff like that. So this shader for epicness. Right, and we need to have something like epic frag file path, right? So we need to have an epic shader. Right, we'll see how it goes. Just a second, I need to quickly close the door. Don't want my neighbors to hear what I'm doing. Right. Alright, so we have that. So this is a simple, and let's copy paste this entire thing, and we're going to say shader for epicness, right? Shader for epicness. 1, 2, 3, and let's say epicness. All right. So, and the shader for epicness is gonna be so it's gonna be simple epic frag, and let's open an image, and let's copy paste some stuff in here. So it's gonna start as just a regional shader, but we're gonna spice it up with glyph stuff. Right, so we'll need HSL to RGB conversion, right? Another thing, so we also take the fragment UV resolution. Okay, so I suppose I can work with that. So we take the fragment coordinates, so that's fine, but that will also mean that we'll need the resolution, right? So let's actually put it somewhere in here. So here is the resolution, and I can't see shit in this mist. Okay, so the next thing is how we compute the rainbow, and the rainbow is computed based on the time. So that means we also need to have the time, the current time. So you can actually pass the current time to the GPU, so you can compute animations based on the current time. Because why not? I mean, why wouldn't you do that? So we have glyph UV background color. I'm not particularly sure why would we do that, and what do we usually set it as? Right, so background color, foreground color. Okay, so let me hard code that for now. So I suppose it's located somewhere in the glyph.c. Background color. What do we usually set it to? So okay, so we usually set BG color. And it's set somewhere here. I'm not really sure why we have a mechanism for setting the background color. Okay, so the foreground color is usually all white and the background color is usually all black. So sure, which essentially means that this is going to be completely zero, right? So, and this is going to be, yeah, so it's just like, yeah, so we can simplify it dramatically. Okay, cool. So we have an epic shader, which is fine. Now let's try to build the entire thing. Compile, because we need to provide the epic shader in here. Shader's simple epic frag, right? Is it going to compile? Is it going to compile? Okay, so we have some conflicting stuff. Right, const char epic frag file path, and in a header, we already have that. Okay, so we have all that stuff updated, which is fine, which is totally fine. So this thing is not used yet, which is nice. I'm really glad that the compiler tells me that I'm not using some variables. Very, very cool. And I'm really glad that it's just a warning, not an error like it would do in some languages. Right. So, okay, so if I try to run this entire thing, it does not properly compile, because why? TC is undeclared. Okay, what's up with that? So I suppose free glyph frag TC is just like, you know, UV coordinates. Yeah. We can put it in here. It's image and it's just out UV, right? It's straight up out UV, nothing particularly special. Okay, so right now we're using just a shader for images, right? So we are using shader for images, that's why it's like a red and stuff like that. But now, if I go and I say shader for epicness, right? It's going to still have a mess, but it's not going to be a red mess, it's going to be a rainbowish mess, right? Well, of course, we'll need to recompile this entire thing, right? So we'll need to recompile. And it is, in fact, rainbowish mess, as you can see, right? So, just a second. Yeah, there we go. So this is basically an atlas of all of the glyphs, and it is rainbowish, right? So, and what's cool is that it's actually synchronized with the rainbow in here. All right, cool. So right now we're setting the UV coordinates from 0 to 1, 1, right? And that's why it makes a mess. Let's actually try to pick maybe very specific sub-image, right? Maybe specific glyph in there, right? So to find a specific glyph, let's actually go to freeglyphs.c and do something like this, right? So here, not really here, but somewhere up there, we recalculate, we basically build the atlas, right? So here's the loop that goes through the glyphs that we want to put in the atlas and puts them in there. So what we can do metrics, and we can take some glyph, for instance, E, right? And we can take its parameters. Specifically, what I'm interested in is the UV coordinates. Right, but I'm not sure where can I get this stuff. So we have advanced bitmap width, bitmap row, and it just depends on how we set UV coordinates. Okay, so the UV position is basically matrix TX, right? So I suppose TX is the thing that we're trying to set. Stepsister Trap, thank you so much for 6 months of tier 1 subscription with the message. Will the editor ever include color schemes? Of course it will. I mean, eventually, sure, why not? Of course, of course, of course, of course. I don't see any problems with color schemes. But basically for now, I'm, you know, just like developing the base. Right? I'm just developing the base. Okay, so this is, we took the metric of a specific thing, right? And this is how we compute the UV position, UV coordinate, and some other stuff. So let's actually say that the metric, it's a glyph metric. All right, so let's put it like this. So there you go, it's a glyph metric. So UV position, vector to F, right? So this is a UV position. And then we're also going to have UV size. Cool. And the thing I want to do, I want to just print all of that, right? So I want to say, okay, UV position X, UV position Y. And then we're also going to have UV size. Right, UV size. I'm going to do exit 69. Right. So let's do this thing. And the only thing I care is the values, right? So here are the values. But this is the size, right? So that means we have to be a little bit careful with this kind of thing. Okay. So let me find this stuff. If 0 and if. And in a simple renderer, instead of this UV coordinates, we'll have to put the stuff that we got from here, right? So that's what we're gonna put in here. So this is basically the left bottom corner, and this is the size, right? And to figure out the right upper corner, we have to actually sum them up. I should have actually done that beforehand, but anyway. So let me quickly do that. I need to add this thing and this thing, right? And this is what I got. So this is sort of an opposite thing, right? This is an opposite thing. And this thing plus 0 is going to be that. Okay, so that's fine. All right, that's cool. So we start from here. So this is the first sort of value. Right, so then we start with an opposing thing. So this is 0, 0. That means 1 is going to be this, but 0 is going to stay. 0 essentially means this, but 1 essentially means this. And this is 1, 1. I wonder if I did all of that correctly. We're about to find out. So there should be also comma in here. Okay, so now, yeah, there we go, it's E. The cursor is E, right? So that means our renderer can correctly get the sub images in there, right? It's capable of correctly getting the sub images. What's interesting is that, can I now mix up different renderers in there? Can I mix up different renders? This is actually quite important. Right, so I set the shader for epicness, right? So this is that. Simple renderer. There we go, we just set that. And after that, I might want to set a different shader. And then synchronize this, and then it draws. But yeah. How can I test that? Because I can try to do the following thing. for color. So then I can do for color. I can try to even copy this thing twice. There we go. And the cursor position. How do we compute the cursor position? So there's no particular way to compute cursor position. We may try to add something like vec2 f add this thing and vec2 f cursor width and 0. So we can add those two things, right? So we add in those two things, and it will basically render another rectangle, but with the color, right? So we have to say solid rectangle, and we have to provide the color. Okay, back to F, actually for FS1, right? So this is going to be white color. All right, so is it going to work? It doesn't really like what's going on here because we're kind of duplicating some of the constants in here. Right, so I suppose duplicating this stuff is kind of meh. So what we want to have in here is factor out those things up there, so they're just the constants, and here we have a little bit of a duplication, but that's fine. Right, so because all of that can be factored out later into something reasonable. There we go. So the cool thing here is that we have rendering of the images and solid color rectangles using the same renderer. Right, we can clearly see that, and it works. So that means we can now proceed to replacing the glyph renderer with whatever we are rendering this E with, and we can greatly simplify the entire stuff. But to do that, we'll have to, we can't just like straight up remove the free glyph renderer. We'll have to factor out the thing that creates the texture atlas. That's very important, right? So none of that here in the free glyph renderer is needed anymore, because now we can basically do all of that in a simple renderer. But one thing that is very important here is building the atlas and also building an array of metrics, right? So metrics that tell where within the atlas we have that glyph located. Right, so I think we're moving in the right direction. Everything is going according to the plan, isn't it? I think it is. Isn't that epic? Isn't that epic, everyone? I think it's pretty freaking epic. Okay, but we don't really need the all right, so that's pretty pogue. But the question is how can we factor out the texture thinking? How can we factor out the texture thinking? So let me see. So freeglyph.c, so here we create the buffers. We initialize the vertex buffers. We initialize the shaders. None of that is needed. And this is where we have some cool shite. Maybe it would make sense to introduce the notion of a free glyph, how to say that, free glyph atlas, like literally like a structure, free glyph atlas. And the thing it does, it just like does this kind of stuff, right? That is it actually. So we also have this interesting thing that computes the position of the cursor, right? So we take a size text. You know what? I think I even know how I'm gonna proceed refactoring this entire thing. I think I even know. Right, so because we can just simply convert the free glyph buffer into the free glyph atlas, and we can only leave the metrics in there. We'll probably need atlas width, atlas height, glyph texture. Glyph texture might be important. Uniforms, I don't think uniforms are going to be important there. Right, so this stuff can get removed, this stuff can get removed. So we can just remove a bunch of stuff in here, and we can follow the compiler assisted refactoring process. The chat asks whether this is pre-recorded. The answer is yes, everything is pre-recorded in here. Everything is pre-recorded. Even the chat, even this message is pre-recorded in here. Everything. All right, so let me see what we have. So before we go, I think I kind of want to maybe commit whatever we have. You know what I mean? You know what I mean? You know what I mean? So maybe I'm gonna actually have that like a separate branch, right? Because I don't want to push that to the master yet. So remove free glyph renderer, or maybe it's called buffer, I think. Free glyph, let's call it renderer, right? So this is gonna be remove free glyph renderer. So, and what we did in here, we basically introduced like several shaders to the simple renderer, and this is exactly what I'm gonna say in here. Introduce several shaders to simple renderer, and I'm gonna push that right into the repo, right? I'm gonna push that right into the repo. So now, since everything is committed, I can safely start removing shit from my code, right? So what can we safely remove? I'm pretty sure we don't need this shit, right? So, and we don't need the free glyph in here as well, right? We do need metric, glyph metric. I think glyph metric is important. We don't need this shit anymore. VIO, VBO, none of that is needed. Atlas width and atlas height is kind of important. Texture is also important. Uniforms not needed. Glyphs not needed. Metrics are important. Free glyph atlas, right? So this is a free glyph atlas. Okay, so this thing, free glyph atlas, is going to be initialized with the free glyph atlas. So maybe I should call it FGA. Or maybe just atlas, right? So maybe just atlas. We'll see. So it feels like it maybe will be too much renaming, or maybe not. I'm not quite sure. We'll see. We'll see. So then we do use. We don't really need to use anything in here. We don't need to clean anything. And I'm pretty sure we don't need to push anything, right? I'm pretty sure we don't. Because all of the pushing is going to be made by the simple renderer. Yeah. None of the pushing here is required. Synchronization, drawing, none of that is required as well. So taking atlas cursor position can be important, right? And render line size, this one is interesting because it is going to still accept the atlas, but it also should accept the simple renderer to render through, because this thing cannot render by itself, but it will be able to render through that thing, right? And yeah, so this entire stuff, this entire interface gets simplified to just 2 structures and 3 functions, right? So it just gets simplified to that, which is good, I think. Right, we also don't need uniforms. Again, it's not doing anything with the shaders, but it's going to be using the simple renderer, right? So we might include simple renderer.h, and here, right, so here we accept the atlas FGB. So this is atlas, and we also need to accept the simple renderer SR, right? So it's going to take the atlas, the simple renderer, and the text. Then it's going to look up the glyphs in the atlas and then pass the corresponding UV coordinates to the simple renderer. So this is how it's going to go. Okay, so let's actually go to the compilation errors and see if it's going to do everything correctly. Okay, so we have a bunch of things in here. Right, so this is Atlas and this is Atlas. Right, in how many places we're gonna have some stuff in here? Alright, so let's just say, let's call this function not render editor into like think. Let's say that it's a render editor, like literally just render the editor, because that's what we're trying to do. Render editor. We accept the Atlas, we accept the simple renderer, and we accept the editor, right? So we accept the also SDL window. So these four things are necessary to render everything, right? Atlas, simple renderer, and editor, and stuff like that. Okay, cool. Alrighty. Cool. So what do we have in here? So here we do the main thing. Here we do the main thing. So we do the use. We don't have use anymore, so we don't need that. Then we synchronize the uniforms. We don't have any uniforms to synchronize anyway. We don't have any of that stuff here. So all of that gets removed. All of that gets removed. Okay, so the next thing I do, I iterate through the lines of the editor. I get the line. I figure out what's going on in there, right? So, and then I'm rendering the line, right? If I take a look at the free glyph, so that's the new function that I need to call in here. So in here I need to provide the Atlas. There you go, here's the Atlas. Then the simple renderer. For some reason I didn't pass the simple renderer as the by the pointer. I think that's quite important. Right, then we provide the text. I might as well actually do something like Atlas, 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 and SR, and that's it, because it's basically the same thing, right? The max line should be computed. Do we even have a max line? Yeah, we do. What is it used for? Line length. Oh, max line. Okay, max line is probably used for the zoom down below. Yeah. So and then we scale. Okay, so that makes sense. Okay, sure. That's fine. All right. So that's basically it, I think, for the glyph renderer and stuff like that. Yeah. So we just iterate through the editor and we just render the line, and that's it basically. So that's how we're gonna get rid of that. So, and the cursor here is an Atlas, right? And we have to provide the Atlas. Buffer init Atlas init. So this is Atlas, and we only need to provide the Atlas and the face. We don't need to provide the shaders because it's not a renderer anymore. It's just the texture in which we're basically storing everything. Right, so Atlas. I'm doing a pretty complicated refactoring, but I'm doing that essentially using the compiler assisted refactoring technique, so it's a little bit safer this way. Alright, so we are done with main, so now we're refactoring the free glyph.c itself. We have some attributes that are not needed anymore. I think they're not needed. So this is an Atlas. So here we should not accept any shaders. We only accept the Atlas itself and the face, the free type face, and the free type face comes from the free type library. Right, I think it's free type 2 library that we're using here. It's that one. So this one, so this is a library that we use for rendering the fonts. I think in the future I'm going to be also using HarvBuzz, right, for shaping. I think this is how we do that. HarvBuzz. Yeah. It's kind of interesting. Like, I recently learned that HarvBuzz was made by Iranian, which is so freaking cool. Who migrated to Canada, of course, but it's still kind of cool. So, and maybe in the future we're gonna use that as well. All right. I actually wonder why Zosin doesn't use SDLTTF, because SDLTTF is kind of limited, and also I don't want my code depend too much on SDL, because this project really is not about using SDL features. It's more about using OpenGL, and I'm using SDL as a initializer for OpenGL. Hope that makes sense. And what's interesting is that SDLTTF, it uses free type anyway. It's an additional library, an additional abstraction. For what exactly? Right, so I'm using SDL, I'm using free type. If I use SDLTTF, I just add another layer that glues together these things. For some reason, I can do that myself. It's not that big of a glue. You know what I mean? It's just like an additional thing to worry about in a build. Like, I can just like use free type directly. Does it make sense? Hopefully that makes sense. What is the advantage of FT over STB true type? Maybe FT is probably more safe, because STB true type explicitly says that you shouldn't use it for security critical applications, which kind of text editors are, because it would be kind of weird if you pick the font on the internet, you put it in your text editor and it just executes random code. That would be kind of weird. So let me take a look at STB true type, but I'm not sure if free type is safe enough. It should be, like, it's used in so many applications, it should be actually safe enough. So yeah, for example, if you take a look at STB true type, it says no security guarantee, do not use this in untrusted font files. So essentially it doesn't do range checks and stuff like that. So the use case for STB true type is probably for asset pipelines in the game development. Right, so essentially how you use this kind of stuff in the game development, you have some sort of like a pipeline where you basically feed fonts, and this thing builds the atlas for you, and the final atlas goes into the final game. So basically this thing is usually used for build step, and using unsafe tools in a build step is kind of fine because you're not running them on a user machine, right? So you're running it on your own machine, right? And you kind of know what kind of fonts you're using, right? You trust those fonts, and you don't force the user to trust some weird fonts on the internet. You know what I mean? Right, so, and that's probably why I would use free type instead of STB true type, because specifically of that. So you know what I mean? Harf buzz means word buzz. Nice, so harf is a word for word in Farsi, right? Probably. Since the author is running, so I suppose it's probably Farsi. All right. Do you think there's a quality difference? Probably. I mean, I wish free type API was as simple as STB true type API. Right, but I mean, I don't know. Okay. All right, so let's actually go and continue with this stuff. So we have the OpenGL initialization shite in there. Right, so this is gonna be, yeah, we don't need that anymore. So we initialize in attributes, vertex attributes, doesn't really matter. Shaders, there's no shaders anymore, so and this is what we care about, the atlas. Yes, give me more of this stuff, please. Okay, so this was just some test code to grab the coordinates of E, and here what we do, we just initialize the textures and stuff like that. Okay, so let's go to the compilation errors in there. All right, so FGB, let's go replace FGB with atlas, like so. Okay, that's fine. Also, I would like to maybe, yeah, I would like to reformat everything. here. So we don't need this function anymore. Clear is also not needed. Push is also not needed. Synchronization also not needed. Draw also not needed. The cursor is needed, I think. Right, because I do remember using it. So this is Atlas, and this is Atlas, and we replace FGB, Atlas, boom. What else do we have? So, and rendering. Rendering is rather interesting. So, what we're doing here, we just push a glyph. But we're gonna be pushing it. It's gonna be interesting. Okay, so here's the Atlas. Atlas. And what we need to accept in here is a simple renderer, SR, as well. As we replace FGB, Atlas, boom. Okay, we're almost done refactoring everything. Unknown name free glyph. Really? Oh, this is because we removed that structure, and that structure is not needed anyway. So, whatever. What's interesting is that now we need to... Where's the position? Where is the position coming from? I'm not sure. Oh, here it is. I see. So we need to replace this entire stuff with a single call to the simple renderer. Simple renderer image rect. That's what we need to do. Right. Somehow. Okay, so this one is simple enough. Sure. And image rect, it probably should accept the UV coordinates, right? So here's the position, here's the size. Maybe we should also accept UV position, right? And UV size as well, right? And we already have everything. So here's the UV position, like just position of this thing. So here's just position, and here's the size. Okay, so we already have everything, surprisingly. Well, it's easier than I expected. What the fuck? So is it gonna be an easy refactoring? Feels like it. It feels like it's gonna be super easy. So we'll just have to extend this function to support this kind of stuff. Okay. And let me comment out this thing because I don't think it is needed at all. Alright, it is needed at all. Let's recompile this thing. What do we have? So simple image rect doesn't compile. Right, so let's extend it vec to FUVP. Can't see shit. Vec to FUVS. So let's go to the simple renderer. Image rect. I even hard-coded some stuff in here, which is funny. Alright, so we have that. Okay, so this one is interesting. So we'll have to do a little bit of a juggling with UV coordinates and stuff, right? Because we have to similarly do UVP, UVP, UVS, UVP. So essentially I have the point and the size of the rectangle, and I need to convert it into 4 points for the quad. Right, and I have to do that for UV coordinates as well, so that's why I have to do this juggling around. But I think once I'm done with that, it should be fine. So here I'm just using like black, and not even black, but completely transparent color with the alpha 0 as the color, because when we're rendering an image, I think it doesn't matter, right? So it really doesn't matter. So let me recompile this entire thing, and too few arguments. Okay, that's fine. And this is because, yeah, we're using this thing. So since I'm rendering the this thing, the cursor, I have to do that slightly differently. So I have to use solid rectangle, and for the color I have to use for FS1. Okay, that's cool. So now I can just like remove this stuff. Okay, what's interesting is that now we don't use anything but the simple renderer. It's anything but a simple renderer, which means that we have to use it and set the corresponding shaders at the top. Right, okay, so we start by using the simple renderer, right? So here we're using the simple renderer. Then we render the text itself. But it only makes sense to render the text if we're using the epic shader, because the text is rendered with epicness, right? So we're setting the shader epicness like this. After that, we have to flush the simple renderer, right? So we have to flush the simple renderer. So here's the text, and we're flushing this entire thing. Interestingly, I might as well just like put it like this, right? So here's the epic stuff. We're rendering everything, so it is rendered by this function, and then we flush everything. So that is cool. Then we're preparing the cursor position, and then in here we have to set the shader that is color. So we're setting the shader for color. Full color. And after we're done with that shader, we are flushing it in here, right? Interestingly, we probably also have to set the vertices count 0 here too. Right, so all of that stuff has to be like tucked under the API of the simple renderer. We'll probably need to introduce something like simple renderer flush, right, which basically takes whatever you have and just performs the draw call. And maybe we have to auto flash every time you set the shader. So it's kind of like, this idea is coming from, you know, simp of Jai, right? So if you take a look, it has a flush method, which is kind of interesting, right? So immediate flush. So let's take a look at the implementation of this function, immediate flush. So this function, basically what it does, it takes everything you pushed into this batch renderer and it performs the draw call, and it sets the you know, the amount of set vertices to 0. It basically flashes everything. So draw call and flash everything. And it's very interesting when it's getting called. It's getting called every time you, for instance, set a shader, right? So let's find the set shader. Set shader. Let me find set shader like this. Let's go there. So every time you set a shader, what it does, it flushes the current state of the renderer, which is interesting, right? Because you can't really perform a draw call and use one shader for one vertices and another shader for another vertices. You kind of have to perform two separate draw calls for that. And because of that, like, you pushed some vertices into the shader, into the renderer with certain shader, and then you want to switch to another shader. So, and it basically seamlessly performs a draw call without you even knowing about that. Like, it's kind of cool that it just performs a draw call every time it is needed, and you don't have to think about it. What you have to think about it, okay, I have a bunch of vertices and I want to render them with this shader program, and I have another bunch of vertices and I want to render them with this shader program, and you just do that. And the renderer basically just flashes things appropriately without you even thinking about it. So I kind of want to like achieve that, and it's pretty close to, we're getting pretty close to that. It's just like I need to get those synchronization and draw calls and tag them under the flush call and call the flush call every time it's needed. Does it make sense? I hope it makes sense, but I kind of like this. Like, what's interesting is that like reading through the library that comes with Jai taught me a lot about programming and also graphics programming and stuff like that. It's really interesting, right? It's just like it's a very like valuable like a library of knowledge, not just code that you can basically copy paste and use. It's also a knowledge. You can just open the code and read and learn something new, right? And it's not overly complicated like standard library of Rust, for instance, where it's impossible to understand anything. It's like abstraction on top of abstraction and stuff on top of abstraction, and where like things go and why it is like that, nobody knows. Here you can open a file and learn something, and John even leaves you comments right, from different years of development, so you can even read them. So there is also like whole articles in how-to, right? For example, at the bottom you have this thing, which is literally just an article in the comments, right? Which is not finished, but maybe at some point it's gonna be finished. Right? It's really cool to just go through this thing and just read and understand. So I'm really looking forward to like this language being finally released, so everyone can just like take this source code and just read it, because it's so fascinating. Clojure has that at the bottom of their files too. Really nice for learning. Interesting. So is the Clojure source code as easy to understand as Jaya? Let's actually take a look. Let's take a look. Clojure, GitHub. Let's test that claim. So here's the source code of Clojure, right? Let's open the source code. Is it easy to understand? So we have CLG Clojure, JVM Clojure, we have assembly. So I'm naturally interested in assembly, and assembly is written in XML. Okay, that's very interesting. Let's open XML. And I suppose assembly as in build, right? So assembly is like a synonym for building here. And there is a slim. So I suppose it assembles something. I thought it's like literally assembly language or something like that. Okay, so I suppose the interesting thing is in JVM. Okay, so we have Java API, but I'm not sure. So there is still ASM in here, so we have some ASM. We have some frame. Let's open the frame. Okay. ASM, very small, fast Java bytecode manipulation framework. It's pretty interesting. So package ASM, and there is some stuff in here, so which explains how things work. So, okay, that's pretty cool. And you have some frames. So this is some constant, this is some constant, some masks and stuff like that. Okay. This looks like something generated by ChatGPT. Like this is straight up feels like something generated by ChatGPT or like Codex or something like that. Those like models, they fucking love to comment on each single definition. Like each single definition is just like, it feels like ChatGPT or something. Right. Okay, so there's some. It's not bad. I've seen worse. Anyway, okay, so let's finish the refactoring. Let's finish the refactoring. I want to go to the rendering in here and just see if I didn't make any mistakes. So we use the renderer. Maybe it makes sense to actually put something like this in here, right? So we use the simple renderer. We set the epic shader, clean all of the vertices, right? We clean. Well, I mean, it probably makes sense to actually clean them every time you flush. So essentially, right, so we can take these 3 lines and pack them into a function called flush, right? So, and we don't have to worry about that. Because flush is basically synchronize, draw call, and clean up all of the vertices array, and we can even put this thing in here. So as you can see, so these 3 lines are basically flush of the renderer. So we render in everything, like we render line by line, that makes sense. Then we flush, then we compute the position of the cursor, everything's fine. So here we set the shader for color, right? We're done with the epicness, we're just doing colors. We synchronize the uniforms. I feel like, by the way, the uniforms has to be synchronized after we used the renderer, because we have a common renderer for everything, so it makes sense to actually like put this thing in here. Though it needs to be set every time you set the shader. Right, it needs to be set every time you set the shader, because every time you set the shader, the locations of the uniforms are screwed up, so that makes sense. And obviously these things can be also tucked under the set shader, just like in simp. So, all right. Okay, so what do we have in here? I feel like I want to move this thing under this block, but I'm not sure if it's a good idea. Probably a good idea, why not? So let's actually put it like this. Alrighty. Cool. So everything's starting to have a structure, and it could be then, you know, compressed a little bit later once we're done. Right, so then we render this thing, and then here what do? We update the camera, right? So we're essentially updating the camera. Right, so here we can even say something like maybe render text, right? So here we're rendering the text. Render cursor, right? So we have 3 sections, and the last section here is update camera, right? So every time on each frame we just do these 3 things: render the text, render the cursor, update the camera. Okay, so let's try to recompile this entire thing. So cursor position, oh yeah, so that's why the cursor position is actually outside of the block, because it can be used by both the rendering of the cursor and the camera updates. So which makes sense. Sure, I don't mind that. Okay, so we have some stuff in here. Okay, so this function ignores foreground colors and background colors. Right, so let's do it like this. Okay, so yeah, we call this thing with that. We don't have to do that anymore. We'll probably have to also update the header, maybe. Okay, I'm surprised this stuff compiles. I'm actually surprised this stuff compiles. And I wonder if it's going to work right away. Right? The reason why I'm wondered is because this is a kind of a complicated refactoring we did in there. It is rather complicated refactoring, so I'm a little bit scared that it might not work. So where is the simple render initialization? Simple render init. Simple render init. I feel like we first have to initialize the simple render and then set the, you know, initialize the texture and stuff like that. I think it makes sense. So if the textures get associated with VAO and VBO and some other stuff, they're going to be associated with the ones created in the simple renderer. Alrighty, so everything seems to be compiled, and let's take a look. Okay, so at least we have a cursor rendering. Is it going to render the text? It is rendering the text. So that's pretty cool. So nothing got broken. How about that? Chat, how about that? Isn't that Poe? So we got rid of the complicated renderer and nothing broke. Isn't that amazing? I think this is freaking amazing. Holy shit. Okay, let's actually take a look at how much we removed. Right, so essentially because we removed a lot of code. So let's do something like, so let's say free glyph buffer, free glyph atlas. Effectively render everything through the simple renderer. There we go. And let's take a look. Can I do the comparison, right? So if we take a look at the distance, right? Yeah. So okay, so we deleted 301 lines, but added 211, right? But this is excluding the simple renderer and like replacement of the cursor. Right, so this is excluding this stuff. We can take a look at the diff in here. Right, and oh well, I mean, we actually deleted a lot in here because of the STB image. But anyway, so the goal of the past 2 streams was to simplify the rendering. We had 2 very specialized renderers, one to render the cursor and another one to render the glyphs. Now we have just a simple renderer which just renders any sort of like shapes primitives and with any color or with any texture, and everything is rendered through that simple renderer, making everything much more manageable, right? So we don't have to, you know, juggle between different renders and stuff like that. And everything can be rendered with this renderer, right? So you can basically take any shape, split it into triangles, maybe texture them accordingly, and that's going to be the thing that you want to render. Right, so now this stuff is much more manageable and I'm super happy. Alright, so let's actually push that right into the repo. Let's push that right into the repo, and I think I'm going to just merge to the master. Can I just merge no fast forwarding E? And yeah, there we go. So I'm going to push that thing right into the repo and remove the branch. There we go. So now this thing should be available for everyone. I hope I didn't break too much. We'll see, we'll see. So that's cool. I think I should be able to remove some of the shaders, like definitely free glyph stuff is not needed anymore. Right, can I just recompile everything and run it without the shaders? Yeah, I didn't think about that, like I don't need shaders anymore. Okay. So, and another shader, so we have a camera in here, and camera is already put in here, right? So that is also not needed, right? So we only have 4 shaders in here. The one for the vertex, right? And 3 for fragments for different kinds of use cases, right? For just color, for the plain color for the cursor, for the just image, but we don't really have any use for this thing yet. And Epic shader that actually does the rainbowish effect. So we have a little bit of math for the rainbowish effect in here. Right, if we try to run this kind of thing, everything seems to be working. Everything seems to be working, right? So, all right. So I did a pretty significant refactoring without breaking anything. Isn't that cool, chat? Isn't it cool? Does anyone have any questions about what we just did? Right. Does anyone have anything? Isn't that epic, my friends? Isn't that epic? I think it's pretty freaking epic. Holy shit. Okay, so let me just commit whatever I just did. Like I removed some shaders. Remove dead shaders. Remove dead shaders. Dab. Right. Yeah. So, and I think I'm done with the renderer for now, so I don't have to worry about, you know, rendering essentially, and I can focus on the features of the text editor itself. Luckily, we have quite a few features that needs to be implemented, right? So we have some to-dos, save file dialog, maybe, file manager. Any modern text editor should also be a file manager, which is true, by the way. Thank you, me from the past, right? So if you take a look at any modern text editor, they always have a file manager integrated into them. Emacs has a file manager, so here's the file manager of Emacs. Vim also has a file manager. Visual Studio Code has a file manager. Sublime has a file manager. Right, so it's kind of like impossible to have a proper text editor without built-in file manager, right? So it's inseparable. Editing text files is also managing text files, right? Notepad doesn't have one, that's why nobody uses Notepad. So it only proves my point. Anyway, so like we also have a bunch of stuff for navigation. Split the line on enter. My god, look at that. So that was implemented before we had a proper representation of the text. Now I can just go in the middle of the line and split the line without putting any effort into that. So I would say this one is done. Deleting line is done. Blinking cursor, I mean, the cursor is blinking. I think it's always been blinking, wasn't it? Look at that. Is it blinking? I think it is blinking. Right. It's not blinking when I'm typing, but that's by design. But when I'm not typing, it is blinking. So I think I'm pretty sure it's blinking. Deleting a word, we don't have deleting a word yet, but we can implement that. Jump forward, backward by word. Right, okay, so look, we fixed 3 to-dos today. Remove irrelevant to-dos. We're gonna push that right into the repo. This is amazing. Jai version when Jai is released, I suppose. I don't know. Will it be ever released? By the way, how many to-dos do we have in this project? So let me see. Build. Okay, so that's fine. Nobody cares about Windows, of course. I'm joking. We're gonna fix it for Windows eventually. We don't really have that many features, right? So all of the features that I want to have in here are these. We probably also need some things like highlighting, or maybe also custom shaders, right? I also want to have a session where I sit down and implement some interesting shaders for this thing. For instance, there's like some shaders for Visual Studio Code. When you type, the screen is shaking, or some particles going around or something like that. We can just go ahead and implement that stuff. Imagine like a camera shaking and like particles going around and stuff like that with this text editor. I think it would be kind of cool. All right. Yeah, so we can have a session specifically for making cool shaders or something like that. We'll see. Anyway. Custom cursors, maybe. Yeah. So imagination is the limit. Imagination is the limit. All right, so maybe we should raid somebody. We haven't raided anyone for quite some time. Do we have anyone to raid? Is anyone doing anything epic on this goddamn website that is impossible to open because it's so slow? Nah. Hero Dev. We can raid Hero Dev, I suppose. So just a second. I need to pause my stream. It doesn't pause right away, by the way. So what is he doing? Come on, Twitch, you can do that. I believe in you. Maybe I should actually turn off the music. And also maybe close the Discord. Close as many things as possible. Yeah, that's kind of weird. Like, I paused it, it still plays. Okay, so let's raid Hero Dev. Right. Alright. So get ready for the raid, boys and girls. Get ready for the raid, and I see you all next time. Love you.